Well, let's get started. Everybody, welcome to Sarah Drake's Lounge, the February edition. And couple notes. One is that we've been invited to do the ARRL engineering book, Radio Astronomy section. It'll be the first one in the engineering book. We've already been published in the antenna book. I am still looking for inputs. I owe them some articles, and I'm going to take them out of the journal today and send them a couple of the example articles to see what kind of detail they want. The difference between the antenna book and the engineering book is they're more concentrated on the receiver side than the antenna side. So they want to see the entire chain with a lot more emphasis on. And his comment was he's not a radio astronomy guy. How do you get these very small signals into your receivers? How do you make your receivers pick up these real small signals? They're very interested in all that. And then I'm going to do the same approach as, we're going to do, the solar the solar telescopes, the meteor telescopes, the, hydrogen versions, the pulsar. The last time I tried to put the big dishes like the Wolfgangs and the deep space dish in, they took those out because they figured that the standard ham radio guy, that's too much for them. That they didn't want the big dish stuff. But I might throw that back in because it's the receiver side, which is almost the same, just adding a bigger dish. And I'll throw in some of Ted's software approach and all the links I could throw in there. That's sort of the approach I'm taking. This is just a draft just to get him to familiar with the kind of stuff we're doing. We have the Western Conference coming up in conjunction with the eclipse down in Dallas. So we've got that coming up. And remember that you don't have to be there. A lot of people are going, but you don't have to be there. You can sign up online. All right, and just go to the web, the Sarah store, and sign up for the online version of that, and we'll have it online. And you'll get all the stuff except for maybe the tours, and the eclipse won't be real. I think they may go out there with some kind of a webcam and try to get the eclipse, but that hasn't been vetted out yet. Let's see, that's 8 to 9 April. We also have the data for the Eastern Conference in August. So start thinking about that. Obviously, if you think about it earlier, the plane flights are cheaper. Anybody else have any more Sarah announcements? All right. And we are working the treasurer. Treasurer is Tom Jacobs, and him and Donna Halen is the assistant treasurer. They are getting the turnover okay. The one problem I'm having that if you guys don't get an email from me or from should be 3 times a month at a minimum that you're going to get an email from the Sarah president or the Sarah treasurer announcing the RTOP, the Drake's Lounge, and the Drake's Lounge Australia. If you're not getting those, please tell me, because that's the one hiccup we're having right now is that the MailChimp account sends that out. But it's based on, the linkages from the store to the MailChimp account and all that stuff hasn't been robust. So I'm a little concerned that some people that sign up for members aren't getting the emails yet, and we haven't fixed that linkages yet. So that's what we're working on. Okay. Let me see. Any other announcements from any of the board members or anybody else online has anything they want to talk about? Okay. Let's go with let's get some of the European folk. Peter East.
Okay. I haven't got a lot, but there might be somebody here who can help me. I've got a Lenovo laptop, which has suddenly decided that the battery can't be charged. It's got 0. But if I use another bit of software, it is fully charged. But it means that it can't be charged, and I suspect that the problem is, and maybe somebody's seen this before, that there's a problem with the BIOS. And the problem is you can't update the BIOS with less than 25% in your battery.
How did you get it to work, Peter? I have one like that, but it's not working.
Well, I can get it working on the charger. I do have a support battery for it, and an external battery, and it won't work from that. But I can turn it on with the charger.
But it won't charge the battery that's in
it won't charge the battery. It says the battery is 0, but as I say, with some professional software, I've confirmed that the battery is still fully charged. So
it ran mine down completely. It refused to charge it at all, claiming it wasn't a real Dell battery.
But the batteries also have electronics in them for charging and temperature sensing, and that may be the problem.
Yeah, but they no longer sell these batteries, so you're essentially causing the laptop to be no longer usable as a laptop, except with an AC adapter is what I've got.
Yeah.
Oh, no.
People have changed the battery, and the problem is still there. I've updated Windows. I've updated the Lenovo software. The only thing I'm left with is updating the BIOS. It is an old BIOS, but as I say, you can't update the BIOS with less than 25% acknowledged in the battery.
Huh. Catch 22.
Yeah, it's a way of obsoleting the laptops. It happened during a Microsoft update in December for mine.
Was it?
I have one of those Lenovo laptops also, and I purchased it from a local fellow that I deal with quite a bit. He does work with salvaging computers. And so let me check with him for you tomorrow, the next day, and I'll send you an email about that. There may be a solution to the problem somewhere.
Peter, did they when they replaced the battery, did they use the approved battery?
I haven't replaced the battery. I've just checked with this professional software that the battery is in fact fully charged.
They may want you to replace it with a Lenovo approved manufacturer.
Yeah.
I've seen software that does that in order to force you to buy a certain overpriced product. That's all I'm saying. Not that you can't work around it, but I've seen it more than once.
Right.
Just an unhappy thought.
Okay. I know it's going to cost me money, but I certainly, a laptop's not a laptop if it won't work on its own battery.
I would say, Peter, I can think of a couple of reasons why this might occur. The first is that the indication of fully charged isn't an indication that you can actually get a full charge on any battery. It just means that's the maximum amount of charge that battery will take. So if you have, for example, your mobile phone, as time goes on in year 2, it will indicate 100% charged, but actually it won't last as long. That's because there's less charge in it.
Yeah.
So if your battery itself has died, and no longer will take charge, then it may well still come up as showing a full charge. The second thing is that would be more. I mean, that's obviously to replace it, and I understand what's just been said, but I'd probably go onto Amazon and buy whatever, or try buying whatever's the cheapest replacement that's available. But the other option, which could be a bit fatal, might be if the charging circuit has gone completely in the Loano, in which case it may not accept a charge at all.
Well, I'm very suspicious because that I'd deliberately fully charged it because I was going away for the weekend, and I confirmed that it was fully charged, and it ran off the battery. But when I got to my destination and I switched it on, it only lasted about 5 seconds before it ran out. So I don't think it's the battery. I'm pretty sure it's firmware somewhere.
So I posted you a private note in the chat, Peter. Just send me an email and we'll.
Okay, shall do, Bob.
All right. You got any? And since that's a real engineering problem on radio astronomy, is there a? You got any other radio astronomy stuff?
Well, I haven't. I use my laptop for all my radio astronomy recording. So
okay, so this is limiting. We need to get you another laptop fix.
Yeah, that's right. Well, that's an alternative.
Okay. And by the way, my hydrogen detector at home with my Spectre Cyber is hooked to a laptop that the battery's dead. So I know exactly what you're talking about. With no chance of ever bringing it back. But it works great on AC. So that's anyway. Okay. So Andrew, since I got you, good segue. What do you got going on?
Me? Oh well. My mum was admitted to hospital with a heart attack about 2.5 weeks ago, which is somewhat taken me out. And plus, I'm back at work now. I've been off ill for a while, so it's reducing the amount of time I've got. However, having said that, my big thing was I presented a talk at European Astrofest in London a couple of weeks ago on muon detectors, which went down quite well. So I was quite pleased to be able to do that. And just shows how useful it is to present things at quite a large forum, because it's a generic amateur astronomer conference, and the UK Radio Astronomy Association stand afterwards had enough people around it that they were blocking the corridor, which is pretty well unheard of in previous years. So it just shows if we can get out there and tell people about amateur radio astronomy, that there is actually a potentially much larger audience of interested folks. The second, oh, sorry, you're going to say something, were you, Rich?
Well, I was gonna comment that we have not added muons to our radio astronomy list of objects, and you think that that's a valid radio astronomy object now that we maybe we put that in the engineering book? Is whatever you got as a detector for muons? Is it muons?
So, well, it's very easy to do, and there's some brilliant detectors available out there. You can even buy one off the shelf from the UK Radio Astronomy Association if you don't fancy soldering your own board. And you've got the option of something which collects science data like these detectors, i.e. something that you can actually analyze, or alternatively, it's not too difficult to make a cloud chamber if you want to demonstrate it. So it's quite a good thing for the public. Would you call it radio astronomy? I guess it depends on your point of view. But certainly here within the UK we are, and at the British Astronomical Association Radio Astronomy Group, it's being treated that way. But I would accept it if other people said that it wasn't.
All right. I don't know if you could send me, I don't know if you got a paper or presentation that I could use for this engineering book. Yeah,
I can send you a copy of the presentation I gave. I mean, and you can see what you think of it.
All right.
Okay, so I'll do that for you. So apart from that, muon detectors aside, for all the people on the group who are saying, oh, we shouldn't be hearing about muon detectors. Oh, can't you hear me very well?
I can hear you fine.
Okay, yeah. Sorry. Apart from that, what else happened? So I learned a very important lesson about interference, which everyone may giggle because it may seem obvious to everyone else, but it wasn't to me. So I've got, as you know from previous meetings, I've got my hydrogen line set up, been mapping the Milky Way quite successfully using TED's ezRA software and an ex-military array. But I've more recently been trying to push the envelope and trying to set up an interferometer. And that is so there's a box there. It's got the computer and the receiver in it, which is about 2 meters away from the array. And I was analyzing the data off the array, and it started to get some very strange traces and some strange sort of data. And I've eventually worked out that, that the other box from 2 meters away was creating significant interference. And I didn't realize just how dramatic it would be. So switching that off made a big difference. So it's an important lesson for me. And finally is the interferometer. So for some reason, I've had a lot of success in the last 6 months setting up radio astronomy experiments, which is amazing. But the one thing I cannot get to work at all is my interferometer. And we can't seem to work out why. I'm very grateful to Jan Lustrup and Mike Ott, both of whom are just being phenomenally helpful and giving up lots of their time to help me to try and get it sorted. But we have yet to get to the bottom of the problem.
Can I ask on your interferometer, and it has probably nothing to do with whether it works or not, is what did you choose for your distance between the two antennas, and why did you choose the distance?
Well, my garden's not very big.
Oh, okay.
Well, not by American standards, anyway. At the moment they're set up for about 2 or 3 meters apart from each other. I can probably go up to about 5 or 6 meters.
So you just basically based on your physical layout, not a real. You chose like a meter for a reason or something like that. Okay.
I at the moment wouldn't understand how to actually work out what distance to choose. Mike's, I know he's online, but he sent me some calculations, and I'm still trying to get my head around them. Apparently, you can calculate how far the fringes will be apart from each other by knowing how far the dishes are apart from each other, etc. I'm just trying to get something at the moment, even if it's just off the sun. I'd just like to get something and say, "Oh, look, there's a fringe." Wow!
All right.
Andrew, there was a comment in the forum. I think it was from. I don't recall. There was a comment on your setup that you may have too much gain. You had three amplifiers, or the no-leg amplifiers in a row, and that also looked to me like a bit too much gain. So you may be overdriving things, or things might oscillate, or so on. So my recommendation would go along the same line and recommend you to reduce the gain. Take out at one of the amplifiers on each channel.
Yes, I'm intending to do that. I will do that. Yeah.
All right. Any other questions for Andrew? All right. Thanks. And Wolfgang, then I got you. What do you got going on?
Yeah, we have started a new observation campaign on yet another FRB. Story is that there was an astronomer's telegram by the Joint Corporation late January about the observation of a new repeat fast radio burst, which seemed to be quite active. It was first detected on the 14th of January, and we started observing that on the 31st of January. And yesterday, was it yesterday? Yes, we had the first success. I can share my screen. This is our first FRB detection of this new FRB. It's the detection is clear, but not quite as strong. But essentially, what the graph shows is the pulse itself. Maybe it's not very visible in this screen sharing. There's a faint line which goes all across the frequency spectrum, which we are observing with 100 megahertz of bandwidth. And the graph below is a so-called bow tie diagram. which shows that the maximum of the intensity is at a DM of around 530 in that range. So this is the expected DM of that. At the moment, there's a preliminary localization by an interferometer experiment, which indicates that this might come from a region of several galaxies, which are about 1.4 billion light years away. So this is our latest result. We keep observing that probably for the next couple of weeks or so, and hope to get some more of these pulses. And that's, I guess, all I have at the moment.
All right, questions for Wolfgang?
Yeah, I have a question.
I was just wondering what the unit DM stands for, actually.
DM is a dispersion measure. It's an indication of the spreading in time over the frequency.
Okay, thank you.
And my question is, how are you scanning the 100 megahertz? Are you getting the full 100 megahertz on the receiver, or are you stepping through smaller chunks and adding it together?
No, it's full 100 megahertz on the receiver.
Are you using a Pluto or what kind of a device are you using for the receiver?
It's a spectrometer, purpose built, so first of all, we down convert that to a frequency range between 100 and 200 megahertz. So this IF then goes on to a digitizing unit, which does a high-speed digitization. I think it's 2 gigasamples per second. And then there's an on-the-fly fast Fourier transform of that signal.
Okay, thank you.
If you want to do that with a SDR, these days that can be done with some of the high-end SDRs. But
Right.
then it's substantial money. The best at the moment, I'm just looking into the options of the SDRs. Probably the best option for radio astronomy might be the Atos Research X4 410, which would give you 4 channels of 400 megahertz each. But that's about 35,000 grand. Yeah, 35 grand.
Okay. My wife won't let me spend that much money.
Well, it's interesting for FRBs, with the exception of the processing, they're pretty bright actually. So it's not that you need a big dish or anything like that. You can probably get them on a tracking. I'm not sure you can do it with a 3-meter dish, but if it's tracking, is that true?
No. You need to have tracking, yes, because if you have a repeat FRB, you want to be on source all the time, and then you wait for hours and hours. This is after 90 hours of observation. Then you get this 1 millisecond event. They are bright, but they're not bright enough for a 3-meter dish.
Oh, okay. So you do need one of the bigger dishes. Okay.
Yeah. It's you might be successful on. I mean, we had a few. Not on this one, but in the other FRB, we had some pulses which were in the 1000 Jansky range. Those might be doable with a smaller dish, but a 3-meter dish, I don't think it's doable. I mean, you would have to be lucky to capture a really, really bright one.
Okay.
And I have to say, I should mention that we are only capturing from the emission of these FRBs only the tip of the iceberg. We are not seeing the lower energy ones. Then you have to go to 100-meter dishes like Green Bank or Effelsberg and so on.
Okay. Any questions for Wolfgang?
I have a question that occurred to me the other day, and I'm sure this has been espoused or has been written on somewhere. Was the famous WOW possibly an FRB?
The WOW signal was narrowband, so therefore it's unlikely to be an FRB. And I don't think it was as short as a typical FRB. I don't recall what the time resolution was.
I don't either. It just occurred to me in passing.
Yeah, I think one of the reasons why people were attributing it to potential extraterrestrial civilization was because it was narrowband. And FRBs typically are wideband, or they are typically 100 megahertz and wider.
Okay. All right, great. Ted, you got anything going on here? You just got back?
I'm going to be unusually quiet. No, I don't have much going on. I'm kind of tinkering with software. I'll let you know when something big happens. How's that?
All right. All right. How's the Hamfest?
It was fine. We had a good attendance. It's nice to have it going again.
All right. Let's see, Chuck. I think that's Chuck Higgins. Is that you, Chuck? No? All right, let's go to Alex.
Good afternoon. I have a few, probably about 8 or 10 slides. It's sort of a closure on this circular patch disk Yagi that I've been working on over the past couple months. It's a short one. Let me show you. Share. Through the window, away from the... See it?
We do.
Okay, so this is, if you go back a couple months, I think December was the first. If you haven't seen any of this before, there's probably a few dozen slides that precede this. But the focus has been to see if it was possible to develop one of these systems, one, to evaluate it, and two, to see if it was feasible to develop and sell kits of these via ezRA. And so the system was shortened up. The original one that I built was 1.5 meters long. This is half. It fits on a 3-foot piece of stainless steel rod. And so this quick presentation just shows you the comparison between, I had been using aluminum spacers. This is using nuts because for the simplicity. And so the past ones that I have been using have had lathe cut aluminum spacers. These are spaced with nuts, and this is to compare the two. And if you haven't seen this before, a few people I think may be new to this, is that it's a series of aluminum discs. This is the driven disc. This is the circular patch feed, and from this point on, it's just what you see. It's a series of Yagi director elements, and they're literally just aluminum discs. These are this combination, and the spacing here is critical. So there's 10 millimeter nylon standoffs. This is the driven element, or the receiving element, and then this is the reflector. And these, on the bottom side of this is the SMA connector, goes through this feed through, and there's a transition from the reflector to the patch feed. And I've made these little elements here. It's a little loop of copper wire soldered to this element, and after this is assembled through the reflector, you solder this together. And so that is the system. The first director is larger, the rest of them are 68 millimeters. And so this is a comparison of the performance. This is the third time I've run through doing a beam pattern characterization. I did this in the backyard, and it surprisingly worked well as compared to the ones that I did out in a large open park area. And what I've characterized here is the change between using aluminum spacers and the nuts and the exposed stainless steel rod. So these are the comparisons. This is the NEC model. Got this from Yeah. One of the online, I got a model and I have modified this, but this is the NEC model, and this corresponds to the field test data. Differences between the aluminum sleeves and the stainless steel nuts. You see a little bit more side lobes, but they're reasonably the same. If you take a look at the beam width, the half power beam width of these is each running right about 30 degrees. There is a little less sensitivity with the nuts. You're losing some energy because of the resistance of the stainless steel versus aluminum, but that's a reasonable comparison. It's a reasonable transition, not having to cut 15 spacers. You lose some in sensitivity. This has been the best that I have gotten is signal versus to cold sky of the bright area of Cygnus at 1.4 dB.
Well, let me get Detlef real quick, since you're in Germany and you got a time zone. You got anything, any projects going on?
Okay. Yes. Hello. Which Detlef speaking. Okay. So I find some new things for my antenna. I think last time I report, maybe I could show it. One moment. That's the same Bildschirm freigeben. Sorry.
Yeah. I'm gonna
okay.
as soon as Alex comes back, I'm gonna drop you.
Yes.
Is that okay?
Okay.
All right. Great.
Okay, I think last time I report I have some RF problems. I think my Raspberry Pi close to the antenna makes many disturbances. Now I put the Raspberry Pi far away from the SDR and the Raspberry Pi far away from the antennas, and so I think it works. And maybe I generate some few results. And I start with a small Yagi antenna. It's only a small one. And I think I find our Milky Way, where I think a bit noisy, but I think I found it. Then I take 4 antennas with a splitter, and I think the results are mostly better. I think we have very good signals, in my opinion. And the last one is different elevation angle, and the last one is with 8 patch antennas, and I think I find a very good signal. And here in this area, I find different signals, I think, from the arms of our Milky Way. And if you look to the poor signal, I think this is the signal direct after the SDR. I think you have a bit noisy, a bit small additional lines. I think they come from the SDR process, and if I make some corrections, I find signals like this in this area. And a few hours later or earlier, I don't remember. I think I find one more arms. I think that's all up to now.
Great.
I think it works. And maybe in future, I try to use phase shifted antennas. I have a phase shifter for the 8 antennas, but I think I start with simple problems. I think all 8 antennas works, all antennas work together, and I think the next step is to combine these antennas. So, okay, it's from my side.
Hi, excellent questions, and Alex is back on. So, any questions for Detlef? Is that how you pronounce your name, by the way? I don't want to keep hashing it. Your first name is Detlef?
Detlef, yeah.
Okay, good.
Mm-hmm.
All right, Alex, we lost you.
Yeah, everything disappeared. Let's try finishing up.
Okay.
You saw this one, right? The comparison of the two?
Yep. That's where we stopped. So go ahead and do that one over again, I think.
All right. So, okay. So what I was saying here, this is the comparison of the disc Yagi antenna with the aluminum sleeves. The whole active surface is aluminum. Once you drop those out, you have both stainless steel nuts and rod, and the resistivity is different, and you have a lower performance of the system. But it still performs reasonably well. That's not too bad. That's that's a sweep through the Cygnus area. It's 7-8 hours sweep, and what you're seeing here is velocity, LSR, local standard rest corrected velocity versus hour angle, and you're looking at the near arm and one of the outer arms. So it still works reasonably well, but I would like to have some input from some people that own non-modified scope-in-a-box systems. And I'd like to compare this to the scope-in-a-box to see if this is a viable alternative. It's certainly to offer, for Sarah to offer these rather than the 1 meter dishes. It's compact. I believe it equals or maybe slightly exceeds the performance. Trade-off being you really can't expand it, or it's difficult to make it 1.5 meters long. And so if anyone has either the Wi-Fi dish or the new 1.42 H1 scope-in-a-box configuration, the Noelec antennas, and could provide me some information using SDR Sharp and IF average. I will, if you send me some data and from the Cygnus region around here, Deck 40, plus or minus around 20-30 hours, I will send you one of the kits. The only thing you need to buy is a piece of stainless steel rod. It would be more costly for me to mail this to you than you can buy it from Amazon. Let me see if anything else. I can send you the spacing on that. What else? The other issue is I've gotten commercial bids for making these discs. This was from Nathan, someone offering to provide a set of all of the discs. These are really expensive, so I'm not sure how to solve this. It's too costly to have these commercially made. I might be willing to make a dozen or two over a period of time, but that's going to limit the number of these things that get produced. They're fairly time consuming to make, but I'm willing to, maybe make a dozen or two if these systems seem like a viable product.
Alex and Ted cut them out of aluminum, and I know that's not as precise, but would that be just giving everybody the dimensions and the material and having everybody do it themselves?
Sure, but I mean, yep, you can do that. But for a kit to be sold, they really need to be made. It's right. And that's what I am potentially offering, is making these things at no charge and letting Sarah sell them. So
okay. And when you're saying how many discs are required, so you're saying like 240 a disc?
Well, see, this is like $130 for all the discs. This guy wants $240 a disc, and then, well, they get expensive. What I was hoping to be able to do is offer these kits for about $50. You get beyond that, you get close to the price of the classic scope in the box with the 1 meter reflector, and they really don't compare. If you could do it for about half the price, that might be a viable option.
Okay, and if for the scope of the box. Go ahead, Bruce.
Okay. Yeah, a couple of comments on that. I'm kind of wondering, Alex, you've done a lot of computer modeling on that disk thing there. And I'm wondering if you could put 2 feed points on a disk that were 90 degrees apart and turn up with opposite, vertical versus horizontal or whatever polarization. If you looked at that, because if you get both polarizations, then you could get either polarization or circular either way with a hybrid down line.
But I don't know that really matters. There is no polarization to H1, and even if it was, the atmosphere is going to spin it around. So the complexity of having 2 SDRs running, adding them, trying to add them together, I don't think you gain anything. I think you double the signal and double the noise and wind up with nothing to be gained, but just more electronic complexity.
What would it take now, since masers are just a little higher frequency, at least the 1630 megahertz, is how hard would it be to convert this to a 1630 megahertz frequency?
Could be done. Just a rescaling. If you want to get here, let me show one last screen here because you can write down this info. Let's see. Take a look at Dr. Vidmar's website. You can just look up Vidmar and S53MV. He has made, I'll have to go back and look. He has made these and modeled them at 3 or 4 different frequencies. And you could sort of scale that off from him. In fact, I used his, this is an excellent model. This is actually at 1.3 gig, and I just rescaled it, and you can proportionally do that. So he has the 1.3, I've got the 1.4, and he also has a 2.4, and so you could just scale it off. You absolutely could do that. No problem at all.
Okay. All right. Any questions for Alex? Good work. Okay. Nathan, you're deep into this stuff too. So what do you got?
Yeah, so let me share. Let's see here. We're going to share this one.
That's okay.
So,
Drake's Lounge was more engineering oriented than the R-Top, so you guys did just fine. But go ahead.
Thank you. So this is something I've been researching lately, reading a lot about, is the galactic dynamics, specifically with our Milky Way, because I am new to the hobby, and I'm also a wannabe. And so one of the papers that I came across recently is I came across a paper from 2016 on the rotational speed of the Milky Way from H1 emissions. And in it, they talked about the tension. There's a tension between released data. Since 1985-ish, they've been using 220 kilometers per second as the VLSR of standard choice. And recent data has actually shown it to be 240. And so it's kind of modifying our current understanding of VLSR. And so what I wanted to do was to look at this and to see, hey, is this actually something that we can measure, that I can measure with my little 1 meter telescope? Is this something I can confirm like that? Because that's really kind of where I'm at with astronomy anyways. And so the causes of the tension, like I said, the IAUs recommended 220 kilometers per second, and that's based off of observed velocities of H1 emissions. There's the paper they cited, Kerr, Linden, Bell from 1986, and the GKT from 1979. But recently, using the VLBI, they've come up with what they're now calling the gold standard for distances across large portions of the Milky Way using MHz. They're doing parallax measurements of MHz to come up with these, and then feed that back into the VLSR equation, and now they're coming up with 240 kilometers plus or minus 8 kilometers per second. So there's that tension because now the error bars are not enough to compensate between the two opinions. So which one's correct? The paper goes on and they say that they believe that the new version is correct, and it's a very short, very interesting read. Highly recommend it. But in it, they give this curve, and so you have velocity, rotational velocity, kilometers per second on the left, and then the distance, the radius from the galactic center. And they show how that increases up to 240 kilometers per second between 5 and 8 kiloparsecs from the galactic center, and then starts to trail downward closer to the 220. And so I have some new data from a better telescope. And so what can I see and how does that compare? And so started looking at it using the my new 1 meter telescope. And right now I only have about 20 degrees worth of data to actually analyze. And those actually fall within these red and green lines on this part of the graph. So kind of hitting the upslope for right now. And so using ezRA, plotted out the rotational velocity measurements. The one on the left is from quadrant 1, but this is actually between minus 163 and minus 141 degrees, or maybe I got that wrong. That's quadrant 3. Quadrant 1 is now 26 to 46 degrees galactic longitude for both of those. And so then using this data, then I pulled all of these measurements out and plotted them against the data that came from this 2016 paper. So basically I'm trying to make my data, see how my data fits against this this line. And so I'm starting to collect some data. It's still very early in the process, way too early to make any sort of recommendations or conclusions or anything. But I am seeing it starting to kind of trend in the same direction. So hopefully over the next 2 to 4 months, maybe I see that going farther out and we can start seeing it go down the same way that they predicted in this 2016 paper. My problem right now, though, is this, you can kind of see there's 2 separate trends in the data. And analyzing it, these upper ones are from the quadrant 1 measurements, and the ones down here are all from quadrant 2. And one of the things I'm really curious about is what might be causing those differences. Why is there so much separation in the data that I can see between the 2 different quadrants? You know, they are opposite of each other, but still quadrant 1 versus quadrant 3, I'm getting slightly different data. So that's still something kind of analyzing, and I'm hoping somebody may have some sort of estimates or opinions, because here by the end of March, I'm hoping to analyze about 40 degrees total worth of data based off of my own telescope, and then create a draft observation report. I'd like to get that into the next journal. And then maybe by the end of May, I'll have 60 degrees or more of data, and maybe I can start making some more concrete conclusions on that. But really, why is there such a big difference between quadrant 1 and quadrant 3? That's really my question of the day.
Well, I can speak a little bit for ezRA. I understand the math for ezRA in the first quadrant, and it pretty well makes sense. I think it is quite sensitive to the velocity you feed into that graph. The highest velocity that you see. But quadrant 3, I'm not so sure about the math, for example, way out there. I copied what JJ had, JJ meant too, and I'm not sure I understand how he got there. Although I've seen the same math from the paper from, I think it's Sweden, with what's that little telescope, sweet little telescope or something.
Yeah.
And I think JJ got the math from them, but I'm not sure I can derive the math. So we need to study the math more closely if you're going to actually believe it as you're doing here.
Okay.
Can you show I'm eager to work on that with you. Off to Wolfgang.
Yeah, can you please show the slide again, the slide number 5? Okay, the question I have is, if you're pointing towards galactic longitude 26 ezRA, how do you come up with velocities at different distances? That's the piece I don't understand.
Yeah, so I'm and I'm glad Ted's on here because he would be the expert. So what I did is I actually took the numbers for each one of these distances as it spits out from ezGal. This is the 550 plot, I think. And it is giving me these different ones, and I guess it's multiple measurements. It's not just spitting out the maximum measurement, it's maybe putting out different measurements, different portions in time or something. I'm not really sure, Ted.
The math came from those 2 papers, JJ's, as well as the Sweden scope. And it works nicely. There's a mathematical trick having to do with the highest velocity that we would see along a line of sight in the first quadrant would be the maximum speed would be a tangential angle.
Yeah, I know that procedure.
All that stuff.
That's also what we use.
And so that only works for the first quadrant. I don't know what you do in the other ones.
Yeah, that's a method that works in the first quadrant. But the point that I was trying to make, if you use that methodology, each pointing towards a certain galactic longitude corresponds to a specific distance. So if you're pointing at one galactic longitude, you can only determine one of the points.
Oh,
so
okay.
This is the piece that confused me when you say you're pointing galactic longitude 29. That would typically give you a certain distance and a certain velocity, but not a number of points.
Yeah. So
yeah. On slide 5, you have 2 red graphs, 2 red lines, and I don't know how you get the lower one.
So I think what we're seeing here, you're only seeing one of the charts. This is actually, this data is comprised of, so like for this right one here, it's from 26 to 46. So there are 20 different galactic longitudes being outputted here. It's just showing it on one graph. I just snagged the first because I went through each individual galactic longitude.
Okay, so each one corresponds to a different galactic longitude.
Different galactic longitude.
Okay,
that's correct.
Yeah.
Yep. So each one of these is a different galactic longitude, and that's what you're seeing here. Different galactic longitudes. This is from that quadrant 1. I put 26. That should be. I should just actually put that as.
Yeah. Okay. Now I understand. But the methodology, as just mentioned by Ted, that only works in quadrant 1.
And quadrant 2, I don't think would have that distance from the galactic center.
Yeah, you can't determine that.
I think it would be farther. That's because the second red stuff.
What you're using is this tangential method, and
that
only works.
Just as bad. Maybe 4, which is like up to minus 180 or minus 90 degrees in my world.
Yeah, if you are in this. In the southern hemisphere, you can take that part as well, and there it also works. The same methodology works, but you can't apply that in quadrant 2 and 3.
So really, that answers my question. Then why is this quadrant 1 data so much better aligned with the theoretical data?
Because, that's simply because
different because it just doesn't work.
The method just doesn't work. Yeah. Okay.
So sorry.
Oh, and I'm sorry, Ted, and I'm not. The other variable in here is that what do you select? There's multiple, because you're actually detecting clouds rotating around the galactic center, and some of the clouds are closer or farther away at the same galactic longitude. and you're supposed to be able to pick. And I forget, Wolfgang, is it the lowest frequency one or the highest frequency one you're supposed to select?
It
And I was
becomes the
wondering if
highest velocity away.
Yeah, is the Easy Gal do that for you, or I mean, does he get a choice of selecting which one he picks?
You get to tune the data a little bit to find that highest velocity that's receding from us along that line of sight. And that works for the quadrant one. I think the lowest receding velocity could work for quadrant 4. I haven't pushed it that hard. And I don't know about 2 and 3. I just kind of following what JJ did, and it makes a pretty graph, so that looks good.
Well, no, I'm just talking about quadrant 1.
Yeah.
For quadrant 1, sometimes you get 2 peaks at different frequencies on the same galactic longitude.
Oh, yes, yes. And what you
Right,
need to do is find the highest receding velocity and use that number. And that,
is that
position we know in space.
Right. Nathan, are you doing that?
Yeah,
Are you selecting?
That's what
because
his
sometimes there's
that's
two.
what his software is doing. Because you can
Right.
you can look at the galactic, you can look at the velocity per longitude, and you can and so you can see the power and the relative velocity. That's what it is. So you can see
Okay.
the relative velocity, and you can see the 2 humps, like where you get a small cloud and a big cloud, or something closer or something farther. And the ezRA software is pulling the bigger stuff, the higher stuff.
Great.
So
Okay.
I need to research how do we actually get better measurements in quadrant 3, or just stick with quadrant 1 and do this data.
I wouldn't even worry about get the quadrant 1 done at all the different galactic longitudes and forget the other 3 quadrants.
Yep.
There's just no, I've got a book here. There's just no, I mean, it's very complicated formula, but they don't get great data. You won't get this curve.
Mm-hmm.
So I'll just abandon those and just do quadrant 1.
Well, then I'll be done with it quicker. So even better.
Yeah.
I think there are mathematical problems with quadrant 4 as well, where we could actually use the same kind of technique. When I've seen the professionals, they just kind of ignore that section. They keep playing with quadrant 1. I think there's something that messes up and puts noise in the data.
So what's the reason for the difference in the slope of the line of your data versus the blue line or the professional line, I guess?
Yeah. So for right now, I don't have that answer. I'm going to need to collect, because I've only got about 24, 25 data points on this one. So I want to collect some more data before I start doing any real conclusions.
And Ted, your ezRA is putting the VLSR data, VLSR corrections in, right?
Oh yes, that's in there.
Okay, so this is actually really close. I mean, for an app, for that, it's really close. Anything else would be just errors in the VLSR, velocity corrections or something.
Mostly the argument I'm passing along with ezRA is that it's a flat line and it's straight across, whereas Kepler would have said it would be a very different shaped line. And how do you explain that? And we say 2 words about dark matter and we turn the page and say, we've run out of time.
Okay, you have to remember, I think this data was taken with a 1 meter dish, so you have a fairly broad beam. So when you're saying you're pointing in a certain direction, like let's say galactic longitude 29, it's actually galactic longitude 29 plus minus 5 degrees. So you're getting a mixture of a certain area. So you're limited in your accuracy as far as the localization is concerned. But I think having said that, I mean, the experiment itself, even with a 1 meter dish, tells the basic story, which Ted has just mentioned. It doesn't drop off towards larger galactic, towards larger distance from the galactic center, as you would expect. And that is the indication of dark matter. So that's all essentially what you can do. And that's fair enough.
Yeah, I'm very interested to see what is actually capable, what are you actually capable of getting out of a small dish? I don't have a 27 meter in my backyard.
Well, the other thing to think about is that, you know, the 240 kilometers per second, you can calculate the mass of the galaxy with that number, right? There's a formula for that, and it's just one of those orbital formulas, basically. And so think about that, is that when you actually get this and it's around 240, then there's a formula to calculate the mass of the galaxy. So now you've got, you know, you've figured out dark matter, you figured out the mass of the galaxy up to the point where you measured the end, which is about where the sun is from the galactic center. As you know, the mass in there. So you've come up with a whole bunch of things using your 1 meter, your little dish, that it probably took centuries for the early scientists to figure out. So you're doing okay.
Again, on the ezRA math, part of the math includes a number called 220, which is, you know, from the same study you're talking about. They've changed their mind. They got a new number. So no wonder our graph kind of ends at 220. There are a bunch of notes in those plots. You can go take a look at them inside the code.
Well, there are actually two numbers which are thrown in. One is the 220, which is the rotation speed of ourselves around the galactic center, as one of the parameters which are thrown in. And the other one is our own distance from the galactic center of the 8 kiloparsec. So those are two parameters that are thrown into the numbers, into the equation. So if those change, obviously, then your measured velocity changes a bit.
Okay, great work. That's exactly the kind of stuff we're looking for. Any other questions for Nathan? Okay, I'm going to go quickly. We got a half hour. Bob Alexa.
Yes. Can you hear me this time?
Yeah, we can. Go for it.
All right. I improved from the RTOP then. No, I'm just a new member, and I read the book by Steve Arnold, who gave me an overview on some of the simple things, and I just joined to see what was going on.
All right. Well, are you on listserv yet?
No.
Oh, I don't know, Ted, if you can put that in the chat so you can get on listserv. And that, so if any project you want to try, all of these guys are like 24 hours a day on listserv. It's a forum that you can put in your, hey, here I want to do this. What kind of a system do I need, and how do I do it, and compare your results and stuff. So that's your 24-hour hotline kind of a thing.
Okay, thank you.
Okay, great.
I want to know what the book was. Steve Arnold. What? Show us a little bit more, Bob. Hold it up. I'm going to take
it. Was it's volume. It's the second edition from Steve Arnold. Radio and Radar Astronomy Projects for Beginners.
Oh, great. Okay, yet another book. Oh, so many fun things to explore. Thank you.
I haven't seen that. Yeah. Okay. Hey, thanks and glad you're here. Rick, hey. K0GD. That's a small.
Hi. Well, I just checked in to see what you guys do in this Zoom meeting. I joined not too long ago, and I'm hard at work trying to decode the notes I was provided by Dan of the Deep Space Exploration Society. He has provided me with all the information I need to do my own data collection and analysis at the dish down in Haswell, Colorado. And of course, his notes are very cryptic and they don't work properly. And so I've spent 3 days now working my way through how to gather and install all the necessary hardware and firmware to do the science experiments on that dish the way they're being done today. I may want to do them differently later, but I need to duplicate what he's done and document my experience in great detail so the next person who wants to do science experiments at Haswell will have a much easier time of putting together the tools than I do.
Rick, are you trying to do hydrogen or pulsars or both, or what do you got set up?
I'm just setting up tools to duplicate what Dan has, which is mostly pulsar stuff at the moment, although it includes hydrogen. The new antenna feed that's being developed, should be installed soon, will include 1.6 gigahertz also. So we'll be able to do more things. But I need to have the basic environments for analyzing the data so that I understand what the current, there's only like 2 people who are doing the science, and all the rest of the 90 members are doing other things, like, improving the disk steering or building a building so we're more comfortable or whatever. I want to get in on the science part, and that's the mystery for most of the members of the DSES. So I'm trying to take the hard projects and understand them before I move ahead, because I've been working in the commercial world for years with NASA and MIT Haystack and other BLBI sites, but I haven't actually done all of the science parts of radio astronomy. So that's what I'm focusing my energy on, the things I don't know yet.
All right, great. Well, you get a hold of me because I'm the one who put the pulsar system together and handed it over to Dan. So I can, and I've got the hydrogen system set up at my house here on a 3-meter dish. All you have to do is you could plug all that stuff into the 18-meter dish down there. So it's not too hard once you have the equipment, and then you just have to do a little training. So I can work with you.
Yep. Well, I'm stuck on getting Tempo installed right now. What I did is I took virtual machines that were bare of anything, and so when I go through Dan's notes on how to install all the different pieces of software that he uses, his notes assume an operating system environment that has things already installed that are not in his notes. And so by setting up virtual machines, I can erase them and start over whenever I like. And I'm finding that there's many missing steps in his notes. And by the time I'm done, his 1-page list of things to do will be about 7 or 8 pages of that I think anyone should be able to follow if anybody wants to set up the system. And hopefully I'll be able to keep it updated with additional software tools and installation instructions and how to use them. As I learn, I'm trying to write it down.
Great. Perfect. Anybody got any questions? Like you're a great resource for this group. All right. Thanks, Rick. I got Waters. Is this the great Captain Anne Flint, or I forget what?
The Pirate Queen.
Pirate Queen. That's right.
So I haven't really been doing anything except trying to do cleanup and setup. The only thing I really want to say, I can't say because we can talk about engineering. Alex Pettit's ray gun. I have a question for him. If
No,
that's
this is the engineering meeting. You could talk engineering here.
well, I had to I had to keep walking away and coming back. So what about a 3D printer? If you have a 3D printer, what is isn't there what material is that they use?
Needs to be conductive.
Like but so it's if it were like carbon fiber, is that no it's no good?
It would take forever. I mean, aluminum is just there. It's no use trying to recreate something.
Well, I was just thinking about if you that you could send out a set of drawings and say, here, put this into your 3D printer, but never mind if the material is not any
I think
it's not suitable.
I think additive manufacturing for this would not be the most efficient.
Probably not. Probably not. It's just I thought I'd throw it out there so you could shoot it down. The other thing that's been worrying me lately is, not this meeting, but the meeting before, Alex's connection went down, and then I was thinking, gosh, I can't hear him at all, and then mine went down. And especially lately, my internet's been really slow. And about the time then I get an email from Anthony saying, did you see that big solar flare? So aren't those things going to affect the internet? I mean, I read a couple things where they said we've been so lucky that we have these huge solar flares, but they just haven't been pointed toward the Earth. So what happens if we get one pointed toward the Earth? Or am I just seeing disaster around every corner?
I'm not sure we have a really good solution for that. You need to know how to cook on wooden stoves and things like that. It's going to change things dramatically.
I'll miss you guys.
We agree. Yeah, well, we'll miss you too.
But I do know how to cook on a wooden stove. I made myself learn. So there. And other than that, we're all good here, and that's all.
Great.
Thanks for all those cheery thoughts. Yeah, that's good.
Yeah, well, I've been doing a lot of other things, and it's probably not healthy. I should be like cleaning the bathroom, not sitting around thinking about all this stuff. But never mind. I'm sorry. Go ahead.
Oh, great. No. And just get all your pirate armament out if this all happens, and you're good. Okay, I'm going to go quickly through.
We want you to get to an antenna and get going. We want to collect some data out there.
I'm going to try to get some new people. We're running out of time. David Adams.
Hi. A good read would be the Carrington event. So
that's
some history. I've been pretty much trying to wrap up the software part and the electronics part of my ASL controller for my the initial antenna is going to be a 1 meter hydrogen line dish, and I've had some trouble integrating software with SDR Sharp. I don't know if anybody else has messed with that. It doesn't seem very open. There's no API. There's no way to control it outside of like a click me program that you write. So I think my plan is right now, I'm just going to point the antenna due south and control it only in AS, let it drift scan for 24 hours and use the IF average to grab timestamps and data. Dump that all into Snowflake or a database somewhere and then start reporting on it. So I do have a quick question, Andy. I think you were one of the first to talk today. The interferometry that you mentioned, is that for increasing resolution or is that for steering?
Is it myself you're talking to there? Sorry.
Yes, yes.
Well, you've got to be careful asking me questions because I know very little and understand even less. I'm just very passionate. But I just want to go. I just want to be able to demonstrate as far as I can. I've got two of the small Newelec 1.4 gigahertz dishes, so I'll just see whether it's possible to do it with that. I'm in quite a very high radio interference area, and I've got houses and things around me, so that might explain why I've had no success so far. But yeah, it'd be wonderful to create a lovely picture of the sky using an interferometer with great resolution, but I think it's not very practical for me.
The reason I ask, and maybe other people could chime in, is I've read a little bit about digital delay lines, like hardware versus software interferometry as far as pointing, phased array type things. Is there a preference? Is there one that's easier? Like syncing the clocks and all. It just seems like it'd be a nightmare in software. But I don't know. I'll ask if you guys have any experience with that.
Well, certainly the interferometer that I'm trying to create, and similar to the one that Mike Ott has done, and I know that Ted has done as well, and also Jan's schematics and things go to me. You to some extent, you can point it at an object, but you can also just drift scan it through. So I think a lot of us, in terms of hydrogen line stuff, are essentially drift scanning across the sky, except people with bigger dishes who might want to get better data by pointing directly at it.
Interferometry is good for small objects. It will not gain you anything for a distribution such as hydrogen clouds.
Right.
Yeah.
It would increase your
from what I
resolution.
understand from a lot of Jan's postings, what it gains you on point light like objects is it gives you a lot more sensitivity to pull stuff out of the noise because you got the interference going on and it makes it visible. And he's been able to actually detect some very small, low level signals with fairly small dishes, which has been pretty impressive.
And also increases or decreases your 3 dB beam width, right? Like you can get better resolution. The 1 meter dish is like 11 degrees or something like that. That's a big swath of sky. So having multiple smaller antennas hooked together in an array, I don't know. I was just trying to figure out whether hardware or software
hey, David, I guess my recommendation is, since you're just starting, Ted has, I think, put together what you're looking for. And he's got the software. If you can load the software, will control the SDR, and he doesn't use SDR sharp. He controls it with this software. And he's also got a 2-element interferometer hooked up, which he doesn't, which basically puts it into a combiner and uses the output of the combiner, a standard analog combiner. So from a starting point, if you go look at or get a hold of Ted and have him help you get the software installed and and I'd just use one antenna first and add and another one second after you get that working. Then I think you're good to go, and you'll get started. And he's got the software does everything. It plots it, and you don't have to go reinvent the wheel on all the different products you can get out. So go look at that ezRA stuff. Ted's online now, and I think that's the best way to get started if you're just starting from scratch. You can almost use any kind of antenna that, the 1 meter, microwave antenna, that's what we're using for the scope in the box. It works fine. And then you heard all the story about all the disc antennas. So that's my recommendation. And are you on listserv yet?
I'm not, but I thank you for the link. Yeah, I saw the link in the chat.
I would recommend you doing listserv and say, hey, here's what I want to do, and let everybody pile on and help you.
Okay. All right. Thank you.
All right.
And Andy, I'll be following your progress too, Andy. So
thank you.
I might be in your behind you in your footsteps.
Oh no, I'll be waiting to see what you do and probably copy you.
Okay, thanks.
But I think it's worth. Can I just reiterate what? Sorry a second. Just reiterate what Alex said a second ago. I think with most of the projects we're doing, we actually get something fantastic out of it. I don't think interferometry, it's certainly the sort of level I'm doing at, is likely to produce any really useful data. It's more of a technology demonstration.
I think comments. I a couple of years ago did a lot with the 408 megahertz interferometer. 2 dishes, 3-meter dishes, about 10 meters apart. And compared to a single antenna with a single antenna at that frequency, I really couldn't pin down more than about 3 discrete sources. And after I got the interferometer going, I could sort out probably 25 or more than 25 discrete sources that actually, identify them as I definitely got it kind of thing. A major difference there because you can wash out the galactic background with the interferometer.
Yeah, but Bruce, I think that the issue is if he's doing it for hydrogen, it doesn't help with hydrogen.
No, hydrogen is not discrete sources. It's extended clouds, and that keeps that from being useful. For just trying to identify discrete sources, the interferometer is very good, but for anything, it's a extended source. It no good.
And unless I'm mistaken, quick question: I can't afford a 30-meter dish, but I can't afford 2 small antennas 30 meters apart. Wouldn't that increase my beam width to be the same as a 30-meter dish?
You turn up with a fringe pattern there, which the envelope of the fringes is the pattern of the dish, and then the you have these alternate fringe patterns going back and forth through there that are at your interferometer determined beam width. So you turn up with a whole bunch of beams, and they get progressively narrower as you get towards the sides of your main antenna.
Okay, and we got a bunch of videos. Look at some of the videos on. We had a whole discussion on amateur interferometry and things like that. And I guess depending if you want to do discrete sources like Bruce was doing, he's not doing hydrogen. He's looking for some other radio object in the sky that's very discrete, which you need, and you get to the bigger antenna you got or the bigger dish, the smaller, the better you can pick that thing out. But hydrogen doesn't matter. You just want to use one dish or one antenna and then get that working, and then you change that or put interferometer on that for more sensitivity or something like that. But I'd recommend one and get the whole receiver chain working, and then worry about the interferometer later.
I'm on that path. Thank you. Yes.
All right, no problem. Jason, we've got a few more minutes, but Jason, what do you got going on?
Well, this is the first time I've gotten on the meeting. I've been a member for over a year, I guess, but I've been I started out a couple of years ago. I just built a hydrogen line corner cube reflector antenna because it was really simple to build, and it actually performs pretty decently. I mean, for no more complexity than it was to build. It has a beam width of about 30 degrees, similar to the Yagi array that Alex was talking about. I don't think it has as high of gain, but it actually does perform pretty well. I started out with that with the what is it, the SDR Sharp software and in the Newelec Salbird filter LNA as my receive chain with that IF averaging plugin, and I just did what I would do is the corner cube reflector was basically set up so that I could just adjust the elevation from pointing zenith in about 15-degree increments down toward about 30 degrees above a horizon. And I live in town, so I got obstructions below that level. So, and I would just do a scan across the plane whenever the Milky Way was vertical, and I would just align the azimuth to the plane, and then just adjust the elevation and take my points. And I did that basically monthly for about 8 or 9 months or a year or so, and looked at all the data. I actually discovered by doing that that there was such a thing as the local standard, the LSR correction that was needed, and so that was a whole rabbit trail that I went on, reading up on that and learning about that. So that's kind of what got me started. Then more recently, in the last year or so, I've been playing around with trying to build a portable dish and get that working, and I have had some success with it, but it's a work in progress, and it's kind of I'm experimenting with with different, each iteration of it, I make some improvement to it, and I'm seeing gradual improvements in the performance. It was pretty poor performing at first, and it's getting into a respectable range now. I think my next upgrade is probably going to be, as Alex suggested, that I switch my cover material to something that's going to behave better, as far as not getting kinked up. Yeah, so that's kind of what I've been doing. I've been pretty much focused on hydrogen line drift scanning. So
great. And so what software are you using to calculate all that? Or do
yeah, so I'm just using SDR Sharp with the IF averaging plugin, and then I'm saving data. I'm pulling the data files from that and then dumping them into Excel and just doing it in Excel.
Yeah. Having been in Excel, I did the exact same thing with Excel. Take a look at Ted's ezRA, which will take all that data and make beautiful plots for you, and you really feel good about it.
Cool.
So I think I think you got to start there, because it sounds like you got the minimum equipment to receive the data now. You just got to be able to process it. So you start seeing some, the galactic arms and things like that. That software gives you, and now you'll be very happy with that. Okay, thank you. And I'm going to get last person I'm going to get to as well. We have time is Vanessa, and I forgot she was in Germany. But Vanessa, welcome. I didn't get you last time, but hopefully I get you now.
Hi, but I don't have anything to report, so thank you for letting me join today and listening to all your exciting projects.
Now, you're just to make sure everybody understands who you are. Are you a PhD candidate in Germany? I think you're working with Wolfgang, right?
Yeah, I'm working with Wolfgang, but I'm a master's student still.
Oh, okay, that works too. All right, and you got a project being thought out here?
Yes, we are still discussing the project for the master thesis.
Okay.
Well, there's so many options, so we just have to go and decide.
All right. Yeah, that's just the way it works. All right. Well, good luck to you.
Thank you.
Anytime you want to come on, and we can gang up on your professor there if he gets ornery. So we can give you some help.
Yeah, thank you. That's great.
No problem. Let's see what I got. Let's see, and we got a few more minutes. Monroe, I don't know if you got anything anymore.
Yeah, I guess you could say it's going to go off on a tangent, so I'll keep it short. I was reading a research article where instead of measuring the amplitude of things using semiconductors, they've actually created what is known as the MEMS chip that measures the force of impact of individual photons, which means you should be able to detect a wavelength by simply digital, analog to digital conversion and read it out. You wouldn't have to like charge up a well, no more CCDs, no more CMOS cameras, like just read the wavelengths directly from the pixels. And I thought that was going way out there. And then I found out that they actually did that as a follow-up research project to another one that was in 2022, where they thought it would be possible, and they did the math part. And then in January 2023 is when they actually found a fabrication that would actually produce the MEMS chip and measured it. It's weird. It looks like a little diving board with a little tiny metal reflector on the end of it. And they measured the deflection of this thing on a per photon level. Just amazing stuff.
All right, that's our next project. Okay. All right. Anybody have any other questions? Remember to record your chat, save your chat, because as soon as I go off, the chat goes away. I'm going to probably edit this a little bit and post it next few days. Also, last comment, the journal is, I just got to finish the edits on the journal tomorrow. And then, so sometime next week, the journal comes out. And let's see. And last but not least, just sort of a thing, Jay Wilson, who's our vice president, is not going to run for vice president again. So we're looking, and the vice president's job is to run the Eastern Conference. So if you want to be involved in the Eastern Conference, my goal is that you work with Jay on this Eastern Conference, so that if you become the vice president and you want to run the next Eastern Conference, you've got a lot of experience with him. So so I'm looking for a vice president who can do the follow-on with Jay and work on this Eastern Conference with him, so he's set for the next one. Anyway, that's my advertisement for the day, and that's all I've got. Have fun. Get on the forum if you're not on the forum yet, and throw all your ideas out there and let these guys help you out. All right, that's all we got. Have a nice week. And Friday is the Friday, or depending if you're in Australia, it's Saturday is the Drake Sounds Australia. If you want to listen to that, that's a real fun group to talk to. All right, night.
Thanks, Rich.
Bye, guys.
Thanks. Bye.
Thanks, Rich. Cheerio.
Bye.